Welcome back to another video of ASAP Physics. In this video, we will be covering the hand rules that we would see with any magnetic field, magnetic force, and electric current problem. Now before we move deeply into the video, make sure you have seen the video on magnetism to make sure you get a better understanding of this video. Now before we move on, let's talk about some basics. What do we use the right hand rule for? Well, we use the right hand rule to either figure out the direction of the magnetic field, the magnetic force, or the electric current. Now, also before we move on, we need to cover a few symbols that we would see in any of these problems. The first one is the X. As you can see here, the X looks like the end of an arrow. Therefore, whenever we see the symbol, it indicates that the magnetic field or any type of vector is going into the board. Now the other symbol is the dot. Well, the dot looks like a tip of an arrowhead. So therefore, the direction of this vector is anything that's coming out of the board. First, let's talk about the first right-hand rule. The first right-hand rule is used to basically figure out the direction of the magnetic field when a current is passing through a straight wire. As you can see here, we have a current that is represented by the letter I moving towards the left side of the wire. Now, the first right-hand rule states that the thumb represents the direction of the current, while the fingers represent the direction of the magnetic field. Now let's take a look at this first example. So as you can see here, the current's moving towards the left side, so our thumb points towards the left. Now, the second step is that we curl the fingers, which represents the direction of the magnetic field. As you saw there, my fingers curled counterclockwise relative to the wire. Therefore, the direction of the magnetic field is counterclockwise to the wire. Now the second example is a little more complicated. As you can see here, we have a dot. And in the beginning of the video, we figured out that the dot represents coming out of the board. So the current is coming out of the board. Now, if we use our right hand rule, we see that the fingers are curling towards me. Therefore, the direction of the magnetic field is counterclockwise compared to that dot. The last rule, which is one of the most important right hand rules to cover, is the second right hand rule. The new thing we're adding to this rule is that the palm represents the magnetic force. The magnetic force is a force that is experienced by any charged particle moving through a magnetic field. So as we can see in our right hand here, the palm of our right hand represents the magnetic force. The thumb still represents the direction of the current or the charged particle, and the fingers represent the direction of the magnetic field. Now before we move on to looking at the examples, we got a quick important thing to cover. Now if we have a positive charge, we would always use our right hand and the right hand rules. However, what would happen if we see an electron, which is a negative charge? Well, then we would use our left hand. The properties of the left hand are super similar to the right hand. For example, the thumb still is the direction of the current, the fingers still represent the magnetic field, and the palm represents the magnetic force. Now let's look into some examples. So as you can see in the first example, the charged particle is going downwards and the magnetic field is going into the board. So now let's use our right hand. So as you can see here, our palm is facing towards the right side of the board. Therefore, the direction of the magnetic force is towards the right. Now let's look at the second example. In the second example, we're looking at something different. The problem has given us the magnetic force and the direction of the magnetic field. Therefore, the remaining component is the direction of the current. So therefore, we need to figure out our thumb of our right hand. So if we use our right hand, we see that the magnetic field is going in and the force is going down. So the palm is facing down. Now, as a result, we see that the thumb is pointing towards me, or the left side of the board. Therefore, the direction of the current is towards the left side.